In this video, we're looking at scientific notation. This is, if you can see here, I have two problems, one from homework 90 and one from homework 93, because they're two different problem types. So the basic two types are ones that start with 0. So this is standard form, this is scientific notation. This is scientific notation, this is standard form. So if you look at the standard form, this one starts with 0 point something. Okay, so this means it's a really big decimal. Notice in that kind, you have an exponent that is a negative number. In this one, we have 80,000. There's no decimal point in it. There could be 0.01, but it doesn't start with a 0. It starts with 80,000. This is a big number, and it has a positive exponent. Generally speaking, if you saw these two scientific notations and they asked something like which number is bigger, some people might say, well, 4.01, I'm not sure which one is it. You would just look at the exponents. 4 is bigger than -5, so this is a bigger number, you know automatically. Okay, so now notice what they have in common. Both of them have times 10 times 10. Okay, that's universal, all scientific notation. Now, in the first one, what you do is you're looking from left to right, and you're looking for the first number that is not a 0. So all these are going to be cut off, and you get to here. You have a 4. So you put the 4 and then a point, 0, 1. Okay? So this 0 is not cut out, and there's never going to be zeros on this side of this kind of number. So you put 4.01. It's always the very first number, and then a point, 0, 1. Okay, like we said, it's always times 10. Now, how did you know it was -5? Well, we know it's negative because it starts with a 0. And this is how we know it's 5. This is where the decimal is. This is where we're putting it. How many spaces is that? 1, 2, 3, 4, 5. So that's where the 5 came from. Now, this is a slightly different case. We had and this is from homework 93. We have 80,000. So what you're going to do now is you're going to look from left to right, and you get the very first non-zero number, which is 8, and you put it here. Now, if it was 8.01, which I'll show you another one of those examples in a second, then you would put a decimal. But since there's nothing else other than zeros, you put times 10, and so the original decimal point is here. We're putting it here. How many spaces is that? 1, 2, 3, 4. So that's how we get to the power of 4. Now, again, if we had, and I'll just make a fresh example here, if we had a number like, let's say 302, so 302,000, right? You would take the very first number, which is 3, put a decimal point, and then 0, 2. Okay? Now, all these zeros are the ones that are going to be cut off. You do times 10. And the question is, how far is it? Now, a lot of people think it has to do with the number of zeros. So this is going to be times 10 to the third. No. It doesn't have to do with the number of zeros. It has to do with moving the decimal point. So the original decimal point on this number, 302,000, is here. When in doubt, do the right thing. The decimal is all the way to the right of your number. And we're moving it to here for scientific notation. So it moves 1, 2, 3, 4. Don't count the comma. 5. So that is to the 5th. Now again, is it a positive 5 or a negative 5? Well, let's look. Does it start with a 0? No. So it's going to be a positive 5. That's really all you need to know about scientific notation. There will be 2 or 3 questions, 3 or 4 on the MSA, and it is an easy thing to get points on.